Welcome back. If you have done all 9 lessons and completed all the exercises and perhaps done quite a few of the challenge questions at the end and passed the assessments up to now, congratulations and welcome to the last lesson of this unit. Welcome to Einstein Helps with Grade 10 Mathematics, Unit Measurement, Lesson 10. This lesson is about spheres, another three-dimensional object. When you look at it from whichever direction, it will look like a filled-in circle. If you have done the questions in section 1 for exploration, you are already familiar with the formulas that we use for the sphere. The surface area is 4 pi r squared. 4 pi r squared is, of course, exactly 4 times the area of a circle with the same radius. And the volume is 4/3 pi r cubed. The 4/3 may look a bit strange, but the pi, of course, we have had in every formula about circles and spheres. And the r cubed will not surprise us because we are talking about volume, which is a three-dimensional measurement. So we should expect the exponent to be 3. Spheres are actually quite common, especially in nature. And the reason is that a sphere is the most efficient shape in that it holds the most volume with the least amount of material. So if we have a soap bubble, we need the least amount of liquid soap to contain the greatest volume of air. Also, the sphere will be a very strong shape because any force acting on it will be spread over the whole area equally. Now we have looked at what a sphere is and what the formulas are. I want to give you 3 examples for calculations or problem solving related to spheres.
Problem number 1. A spherical hilltop water reservoir on the campus of Montgomery College in Germantown, Maryland, is named the Earthoid. 2 bits of information are provided that are of interest for us in mathematics. It says the tank is 100 foot in diameter and it holds 2 million gallons of water. One US gallon is equal to approximately 3.785 liters.
Let's do this in metric. So we get 3.785 liters times 2 million. So I do 2 times 3.785 equals 7.57. So the capacity of the tank is said to be 7.57 million liters. Now, a liter is the same as a cubic decimeter. This is something you have to memorize. If we have a cubic decimeter here, the length, the width, and the height will be 1 decimeter. So if we have 10 of them in a row, and then 10 rows behind each other, and then 10 layers stacked on top of each other, we have 1 cubic meter. And 1 cubic meter will be 10 times 10 times 10 is 1,000 liters, or 1,000 cubic decimeters. Volume of the tank, that's the interior cavity, will be 7,570 cubic meters. To find the interior diameter, I have to use the formula for volume, and the formula is volume is 4/3 pi r cubed. We
We know that the volume is 7,570. So I fill in 7,570, being in cubic meters, is 4/3 times pi times the radius cubed. So what is radius cubed? Divide both sides by 4/3 pi. So radius cubed is 7,570. Divide by 4/3 pi. 7,570 divide by brackets 4 times pi divide by 3 bracket equals 1807 is approximately 1807 cubic meters. The radius is then the cubed root, so I go second function here, cube the root out of the answer equals 12.18. So the radius is approximately 12.18 meters. That means that the diameter would be 24.36 meters. And that's the interior diameter. Now the exterior diameter here was given as to be 100 feet. And we have learned that 1 foot is about 30 centimeters, so this is about 30 meters. So that means that the wall, 2 times the thickness of the wall, is the difference. Or I can say the wall thickness, okay, the thickness of the wall is the difference, 30 minus 24.36 divided by 2. And this will be 2.8, a little over 2.8. The thickness of the wall, 2.8 meters. This is highly unlikely. This is huge. This is much too heavy. So this cannot be correct. Perhaps the 2 million gallons is not the total capacity because the liquid will expand in summer times, and there probably needs to be an airspace above the water. And secondly, the 100 feet diameter is probably exaggerated and rounded up. So that's my idea, because 2.8 meters is way too much material. So that's the first question. What would be the thickness of the tank wall? This leads us to the second question. If the concrete stand takes up 5% of the surface, what area had to be painted to look like a globe? So now we have to look at the external data, and we have to find the surface area and then take 95% of it. The surface area of a sphere is 4 pi r squared. In this case is 4 times pi times 900 is 3600 pi. 11,309.73 is approximately 11,309.73 square meters. And we said there is a concrete base under the globe, and we assume it takes up 5% of the surface area of the ball, and so we are left with 95% to paint. So we do 95% times the surface area is the area to be painted. So I take this times 0.95 equals 10,744. 10,744 square meters. And that is the answer to question B. For the second problem, we are looking at a mirror ball that you can purchase online. and it is given that this mirror ball made of stainless steel has a diameter of 58 centimeters. And also the density of stainless steel is given to be 7.7 grams per cubic centimeters. So what would be the thickness of the wall? Three options are given: 2 millimeter, 4 millimeter, or 6 millimeter. I think it is clever to start with 4 millimeter, and then we can see how likely this is if the mass should be greater or less, given that customers say that it was light or even very light. So we know it's not solid, obviously it is hollow, and what would be the thickness of the wall? So we will start with the assumption that it is 4 millimeter. Okay, thickness of the wall is 4 millimeter, and so that means that the material will be volume of the outside dimensions minus volume of the inside dimensions is the amount of steel used. The volume of the outside dimensions is 4/3 pi r cubed, and r is the half of this, so r is going to be 29 centimeter. 29 cubed minus the inside, and for the inside we have 4/3 pi times, and the thickness is thought to be 4 millimeters, so that means what is left of the 29 centimeter is 28.6 centimeter. I can save myself a little bit of calculation if I put the 4/3 pi out of the brackets, and I first calculate the cubes and the difference between these. Okay, here we go. I start with 29 to the power of 3. Watch out that you go over 1 so that we don't stay in the exponent. Minus 28.6 cubed equals, and the answer is 995.344 is 4/3 pi. Better write an extra step in the calculation so that you can communicate very clearly what you have done. So if there's a mistake in there, you can find it and the corrector can find it. And the answer is that the amount of steel is 4,169.3, and this is cubic centimeters. And it is said that every cubic centimeter should have a mass of 7.7 grams. So I do this times 7.7 to get the grams, and divide by 1,000 to get the kilograms. So the mass would be 32.1, approximately 32.1 kilograms. Well, and this is for a thickness, okay, for thickness equals 4 millimeter. 32.1 kilogram is not light, and is certainly not very light, so actually the wall will be quite thin. If we take 2 millimeters, it will probably be just over half of this, maybe 17 kilogram. Even that is not light or very light, but if you see that you have this big ball made of stainless steel, in comparison, what you would expect, it would be actually quite light. So my suggestion is the thickness of the wall would be about 2 millimeters, and certainly not 4 or 6 millimeters. this is my answer.
So I hope you're not discouraged in this unit on measurement. In fact, I really hope that you love mathematics and that you have been encouraged to do the work, to learn new things, to explore things, to discover things, and that you will go on with the rest of grade 10 mathematics. First do the rest of the exercises, the practice, and then do some of the exploration questions, and then good luck on doing the assessments. If you do well and you get good results, you can move on to the next unit. Good luck.